Hello everyone. Hope you're all doing well. Hope you're all happy. Today we'll be starting a series of videos called Recursion with Vectors. And we'll be using vectors and strings a lot from the standard template library. So I assume you're familiar with those, but for people who need a recap or something, I'll be doing a very basic introduction to vectors and some functions of strings. Okay. Okay. What are vectors? Okay, vectors are basically arrays, but the main difference is that vectors are dynamic. What do I mean by dynamic? Let's say you have a vector of size, you have an array of size 4, okay? And you store 1, 2, 8, 9, any elements, 4 elements in an array of size 4, and everyone is happy. There is no problems. But the problem comes when you want to add a fifth element, right? In C++ and in most languages, the memory allocated to array is continuous, and you cannot just add stuff here, right? Well, that's not possible because in the memory here there are something else, here there are something else. We cannot just add something to the array. So what we do is we create a new array of size something bigger, we'll create an array of size 5. Now we copy all the values, and now we add the fifth element we wanted to add. But this is very inefficient, right? So to solve these problems, vectors are introduced. So vector can keep on adding elements, but we don't have to manually resize the arrays. We won't be looking at the deep working of backend working of array vectors. For that, there are videos in Pepcoding. You can watch that. Okay, vectors. How do we declare a vector? To declare a vector, we say vector and data type. This data type can be primitive or non-primitive. We'll say int arr. Arr is the name of the vector, and that's it. That's the declaration. This can be also, we'll be mostly using strings. Okay, so vector of string arr. That's the declaration. And to add elements to this vector, what we'll do is we'll say arr dot push back, and push back the string we wanted to add. This is a string vector, so we'll add, okay, let's say ABC. Okay, now now we can add elements. Let's say arr dot push back of, let's say XYZ, something. You can keep on adding this. Also, one of the other advantages of vector is that it keeps account of the size of the vector. You know that in C++, we have to keep an account of the size, right? We have to keep in mind this is the size of the array, this is the size of the array. But in vector, whenever you say the name of the vector dot size, it gives the size of the vector. So here the size is 0, here the size is 1, here the size is 2. Wherever you call this function, it gives the corresponding size. That's enough of basic introduction for the series of videos. We'll look at a few functions of strings also. Let's say we have a string A, B, C, D, E, F. Okay. Let's say we have the string. Now, if you want to get the this character, okay, let's say you want to get the character at the 4th position. How can you get that? We know that in C++, each string is a character array. So this is the index of, this is index 0, 1, 2, 3, 4, 5. Now, if we want the element at the 4th place, we get the index at, we get the character at 3rd index, right? So for that, there is a function called s.at. These are all in the standard template library. So we say character ch is equal to s.at 3 if you want the character at the 4th position. You can also say s.at 0, that will get you a. Okay, keep in mind this function s.at, the name of the string .at. We'll need this for the following question we are going to solve. Also, I'd like to introduce another function, that is substring. Let's say we have a string of A, B, C, D, E, F, the same old string. Let's say you want a substring of this. only this. You want to cut out first and last elements. Okay, what you have to do is you say s dot substring str, and this function takes two arguments. The first argument is the index of the starting letter. Okay, this is index 0 1 2 3 4. This takes 1, then we want from B. Okay, and the second index takes the size of the answer. So the size of the answer is 1 2 3 and 4. Okay, so s dot substring of, it takes two arguments, the starting index and the size of this string, what you want this string to be. We'll solve one more. If you want D C D E F, okay, you say substring of 2 comma 4. You want DE, you say substring of 3 comma 2. Okay, this is how you use substring. Okay, keep in mind these two functions. This is enough for solving this problem of subsequence. So our first problem is, you are given a string, and without changing the signature of this function, what you have to find out is you have to calculate all the subsequences of this string. Okay, first of all, what is a subsequence? It's a new word, right? Let's see what are subsequences. Let's say a string of A, B, C, D, E, F. Same string. It is big, so let's take this. Okay, it's 6 elements long, so we'll use this. What is a subsequence? A subsequence of a string is a substring where any element can be deleted. Okay, any element can be either deleted or not deleted. The resulting elements should be in the same order. Okay, what do I mean by this? I deleted B, I deleted C, I deleted D, I deleted F. Anything can be deleted. I deleted these 4 letters. The resulting string is AE, right? This is called a substring. This is obtained by deleting any number of letters from a string. The main thing is that this should be in order. Okay, first element was A, and E comes after A. Okay, that is the main thing with subsequence. The elements are always in order: A, B, C, D, E, F. Let's say you delete the first 3 letters. Okay, done. D, E, F. It's a subsequence. Let's say you delete all B, C, D, and F. Okay, that's what we deleted first. So B, C, D, E, F. Everything we delete all these things. So we are left with A. A is also a subsequence. So in a subsequence, what happens is D, E, F. Each letter can either be the subsequence or not be the subsequence. Okay, let's do this with a smaller string. Is equal to A, B, C. Okay, now let's write out all the subsequences of this string. First we'll remove A. Okay, the resulting is BC. Okay, then we remove B, the resulting is AC. Then we remove C, the resulting is AB. We deleted 1 letter so far. Now we'll delete 2 letters. We'll delete A and B, we get C. We delete B and C, we get A. We delete A and C, we get B. Okay, we deleted 1 letter, we deleted 2 letters. Let's delete 3 letters. Okay, we get an empty string. This is also a subsequence because we deleted any number of letters we want, and the resulting string is in order. I mean, it's in the proper order, right? There is no elements. It is same as it is in the same order. Let's say we don't delete anything. A, B, C. This is also a subsequence because the resulting letters are in the same order, and we can either delete or not delete. And this time we chose not to delete. So for a string of length 3, what happens is there are 8 subsequences, right? How is this possible? Say S equal to ABC. Each letter has a choice of either being in the substring or not being in the substring. So A has 2 choices, B has 2 choices again, C has 2 choices again. Each letter will have a choice of either going into the string or subsequence or not going into the subsequence. So each letter will have 2 choices. So if the number of letters is n, okay, the length of the string is n, we'll have 2 power n subsequences. It's basic combination mathematics, right? Each letter is having two choices. So that's how we get 8 subsequences for a string of ABC. Alright, now we have to code this in the computer, right? We want the computer, what we want to do is we want to give if we give an input of ABC to your program, the program you're going to write, okay? If you're going to give an input of ABC, we want to get this output. Also keep in mind, we have to store each string in a vector. That's why it is recursion with arraylist. This is made with Java in mind. Now we are learning C++. So each string should be in a vector. Each string should be in a vector, and we have to print the vector at last. Printing is taken care for you. You just have to get all the subsequences and store it in a vector. That's our question. Now I request you to pause the video and try to solve it by yourself. I mean, solving will help you improve your programming skills. You can watch a woodcutter cut wood for like 10 days, 24 hours a day. But when you try to cut wood, you would not be able to. So practice is the best teacher. So I request you to pause the video, however long it takes, try to solve it. If you can figure it out, great, compare it with my answer. If you can't, it's okay, we'll solve, you'll get it after in due course of practice, you know. So I request you to pause the video and solve this question by yourself. If not, you can continue. I'm solving the question now. All right, let's go. What we have to keep in mind is, we are given a clue that we are solving it with recursion and vectors, right? Recursion. Whenever we talk about recursion, what we have to keep in mind is faith. What the faith of the function is. Now, how we are solving this is, each letter in here will have a choice of either being in the subsequence or not being in the subsequence, right? What we have a faith is, I'll remove the first letter. Okay, I'll remove the first letter in the character A. We'll save it in this, and we'll have a faith that this BC will go and it will get all the subsequences of BC. Okay, it will get all the subsequences of BC, and what we'll do is we'll add the first letter to this, or we will not add to this, and finally we'll have our answer. Let me go once again. We'll remove the first letter and we'll ask the remaining string to go and find its subsequences in an array list. And what we'll do is this A will have two choices. Either we can include in the subsequences or not include in the subsequences, and that way we'll get our answer. Okay, let's code this, and you'll understand when we code it. What we have to do is we have to get the first element, right? I told you in the starting about a function at. We get an input of s. Let me make it a little bigger for you. It will be easier on your eyes. Th equal to s dot at 0. What we're doing, we're getting the first letter. Now what we do is, after getting the first letter, what did we do? We separated the first letter and made this string, right? So it's a substring. How do we get this substring? We start from index 1 and the length of 2. So to do that, we'll say string rest of the string is equal to s dot substring of 1 comma the previous size minus 1, because we are removing one element here, right? We are not removing, we are adding this. In this rest of the string, we want the size to be 1 less than the previous question. Okay, now what we do, according to our faith, we say hey subsequence, go and get hey substring, hey rest of the string, you go and get your subsequences. So we'll that returns a vector, so we'll store it in a vector. Okay, vector of string recursion answer. Anything, you can name this anything. I'm saying it is the recursion answer. This recursion answer is GSS of the substring, the rest of the string. Okay, we have faith that this will work. We don't know anything. Okay, this got us all the subsequences of this rest of the string. What my job is to add this ch either to, this ch can have two choices. It can either add to the answer or not add to the answer. So that's what we'll write. For each string, we are using a for each loop. For each string in recursion answer, okay, before that we'll make our answer. We have to return this, okay, string my answer is equal to, we'll just declare this. For each string in this recursion answer, we'll do my answer dot push back what, this string. Here we are not adding our character to it. We have another choice. What we can do is, for each string in recursion answer, we can also add ch, right? So my answer dot push back is ch plus str. Okay, so that's the solution. Now we have to figure out the base case. First, let's see. Our string is ABC. What happens is, we remove the first letter and we say BC. BC, go and find your subsequences. What BC does is, it says, I'll remove first letter. C, go and find your subsequences. What C says is, I'll remove the first letter and you find your subsequences. We cannot remove the first letter anymore, right? So this is our base case. What is the subsequence of an empty string? We know that every string is a subsequence of itself. Okay, that's a property. Every string is a subsequence of itself, and also empty string is a subsequence of every string. Here both are the same. So this empty string subsequence is an empty string. So whenever we find an empty string, we return an array list. We return a vector with an empty string. Okay. Now let's code this base condition and we'll check the results. So if s dot size is equal to 0, if it is an empty string, create a new vector of strings. This is base answer. Okay. Now what we do is, we add an empty string to this base answer. Dot push back an empty string, and we return this base answer. Okay. So we return the base answer, and that is caught by this, and it will add the character or not add the character and return another array list. This keeps on going. Okay, let's see if this program works. Okay, it is showing segmentation fault. I'll fix the error and I'll be back. All right. We did a very basic mistake of not returning the answer. Okay, we have to return my answer. All right. What we do is, based on the recursion answer, we add our first character or not add the first character, and we return this vector. Let's try to run this. Yeah, it works as expected. Okay. Now we'll dry run this code once so that you get a better understanding what is going on. All right. We'll get an eraser and all right, that's enough. Now what we have is, we have a string of ABC. This is got by the input on the main function, and it passes to this function, right? What happens? It checks if the size is 0. The size is not 0. So it takes the first in first character in ch and sends the rest of the string and says go and find the subsequence again. This also size is not 0, so it takes the first character, says to C, you go and find your subsequences. C takes the first character and says to empty string, you go and find your subsequences. In empty string, the size is 0. It has no characters in it, so the size is 0. The base case is executed. It creates a vector. Okay, it creates a vector. It adds an empty string because empty string is a subsequence of empty string, and it returns to C. Now C says C will create a new vector. Okay, and it says for each element in this recursion answer, this is the recursion answer. For each element in the recursion answer, I'll add this letter I removed. I removed C, right? First we are not adding, so we are having the string as it is, and now we'll add myself to the empty answer, to the empty string. So it returns C, and it returns this to BC. BC creates a new vector, and it says, okay, for each element in this recursion answer, I will not add anything. I'll add myself, the element I removed, B and BC. Okay, this is returned to ABC, and ABC creates a new vector again. It says for each element in this recursion answer, I'll not add anything, B comma BC, and I'll add the first character I removed. Okay, I think I got it here. It says I'll add myself, the first character I removed, to each element of the recursion answer. So it's A, AC, ABC, AB, and ABC. And this returns to the function call. So what called the function? We know the main function called the function, and it stored it in an array list. And it stored it in a vector here. This vector is printed by this function, and that's how we got the answer. I hope you understood the program. I hope you understood the problem. If you have any doubt, you can leave it in the comment section. We'll try to answer it. If you like this video, you know what to do, and subscribe to Pepcoding. Share this video with your friends. Thank you.